Welcome back, friends. In today's class, I'm going to talk about energy. The definition of the energy is the ability of a body to do work, and the units of energy is joules. Now, if I wanted to get into the details of this, let's look into what is work first of all. So, work, if I look into the again definition of it, the work is it's a form of energy. And let's look into how it's a form of energy. So we can first of all we can also see that work and energy are literally one and the same thing. So let's look into how. So if this is object and this, let's say the mass is 10 kgs, and the net force F net on this object is 100 newtons, and because of that 100 newtons, this object end up covering a distance of 5 meter. I wanted to find the work done. So formula for work done is work done is equal to force times distance moved in the direction of force, in the direction of force. So now force is 100 newtons, and times distance moved is 5, so work done will be equal to 500. I can call it as Newton meter or joules also. So 500 joules or 500 Newton meter, both are units of work. Work is a scalar quantity. If it is a scalar quantity, so energy will also be a scalar quantity. Now, we said that work is a form of energy. In the same way, there are different forms of energies. Energy. One which we've studied, work. Another form of energy is kinetic energy. Another is potential energy. Now let's focus, and then there is another form of energy, internal energy also, but this is not of our concern, so we won't talk about this one. We will only focus on these two forms of energies right now. So potential energy. So what is the potential energy? Potential energy is that form of energy which is because of the height of the object. So because of height of the object with respect to ground. All right. So what do I mean by height of the object with respect to the ground? So first of all, whenever I wanted to measure the potential energy, I'll consider a reference ground. So if this is my reference plane from where I'm considering the potential energy, and there is a table placed on this plane, and then there is an object placed here, and the mass of this object is, let's say, 2 kgs. Now I wanted to find the potential energy. So if I ask you what is the potential energy in this ball or in this object which has a mass of 2 kgs, you will say this question is incomplete. Why this is incomplete? Because I wanted to find the potential energy with reference to something, whether it's with reference to this or whether with respect to this surface. So that's what we need to know. So now I will complete my question. I'll say what is the potential energy in the object, with respect to ground or location 1. I will name it as location 1, and I'll name it as location 2. So with respect to location 1, potential energy will be mgh. This is the formula for potential energy. So potential energy value will be equal to 2 times, mass is 2 times, g value is 9.81 times height. Height is how much? Height is, let's say, I'm gonna call it as 3 meters. So this is 3 meters. So this value will be equal to 2 times 9.81 times 3, which will be 58.86 joules potential energy. And now if I ask you with respect to this question, I'm going to erase this and gonna get into the detail of potential energy. If I ask you what is the potential energy with respect to location 2, then what are you gonna say is this is the location 2, and now with respect to the location 2, the potential energy is again mgh. So mass is 2 kgs times 9.81 times height with respect to this location is how much? 0. So potential energy with respect to that location becomes 0. Okay, so now that's why. So did you understand why this location is important? So this location will tell me how much the potential energy is in an object with respect to that particular point. Now if I go into the little more details of the potential energy, so energy, before I get into the detail of potential energy, energy gained, we will consider it, although it's a scalar quantity, but there are little some sign convention which we need to follow. Energy gained will be considered as positive, energy taken out of the system will be considered as negative. All right, so if the question which we just did, in this one, this was the location 1. Okay, and let's suppose the object, I'm gonna go to the next page. So the object is right now placed on this ground, and then in the second instance I take this object and I place it over here. So what's happening? Is the energy gained by the object with respect to the location 1? You will say yes, now the energy has been gained by the object. So that's why we will consider it as positive value. So I will say mgh, which we figured out, which was 2 times 9.81 times 3, which came out to be something like 58 point something. Yeah, 58.86. So 58.86. So anything upward we consider it as positive. So height moving, when we moved upwards in height upwards is positive, so I consider this value as positive. Now what I'm going to do is, let's say the ball is placed here, and then I take this ball from here to down here. Now I wanted to find potential energy with respect to location 2. So from here the ball is moving in the downward direction about a height h, and this was we consider as 3 meters. So again potential energy formula is mgh. So I will write it as mass of this ball is 2 kgs, 2 times 9.81 times 3, but this 3 will be negative because the height which we are covering, we are moving the distance in the downward direction, guys, here downward direction. So that's why this will be negative 58.86 joules. This negative is just that you're moving the height, you're moving in the downward direction, and then if it is a positive value, you're moving it, the potential energy is adding into the system. So you're moving upwards. So hopefully you were able to understand something about the potential energy. I'll see you in the next video when we'll talk about the kinetic energy.